Okay, everybody, what we're going to look at in this video is something called critical values. So critical values, specifically, we're going to look at something called the z-critical, and we denote that by z with a little star. And this z-critical, this is the critical value coming from how confident we want to be. Okay, we talked about confidence intervals earlier. So this critical value is linked directly to that. So if you want a 95% confidence interval, you have a specific z-critical that you use. If you want a 90% confidence interval, you have a specific z-critical that you're going to use there. Now, like I told you in the previous video, in the confidence interval video, you are typically only going to use 95%, but we will see some others. There are 3 specific ones that you have the possibility of running into: 90%, 95%, and 99%. These are the most common confidence intervals. Okay, so those are the 3 most common. And each one of those has a particular critical value that is associated with it. And these could be found on your table, but really for these 3, it's going to be best just to know these. Okay, these 3 you just need to know. Because when we find them on the table, we actually estimate a little bit. So we want to know the exact critical values for each of these. Now, what a critical value does, the critical value specifies the number of standard errors needed. So if you think about looking back at the previous video that I did with you, when we did a 95% confidence interval, we went 2 standard deviations from the center, and that was what gave us 95% of our data. And that's one that's pretty common, and it uses, in terms of standard deviations, that would just be 2 standard deviations. Now, when we're using different ones, we have to specify how many standard errors we are away, and that's based on the samples that we have, and hopefully then that interval will capture our true proportion. Okay, so let's look at an example of finding a confidence interval using these critical values. So, for example, let's say that a random sample of 78 students at a university revealed that 49 carry their books in a book bag, as opposed to just carrying them in their arms. And we want to find a 95% confidence interval for this. So we want to no longer base it just off of our sample, we want to base it off of the entire population. So that's what we want to come up with. So some of our information that we have in a 78, we can come up with our sample proportion, which is 49 out of 78, which is approximately 0.063 or 0.63. Okay, now to calculate the 95% confidence interval, or really to calculate any confidence interval, the formula that we have p hat plus or minus our critical value times the square root of p hat times 1 minus p hat over n. So this part should look familiar because that part is how we calculated our estimate of our standard deviation, okay? And when we calculated this before, when we did a 95% confidence interval, we just went 2 standard errors away from the p hat value. So now we can do some custom value, okay, because this refers to how many standard errors we are away, and then this gives us our standard error. So this should look familiar. So if we want to do a 95% confidence interval, we are going to do our p hat, which we are going to use 0.63 plus or minus for 95%. If you come up here and look at our critical values, 1.96 times, we're going to do the square root of 0.63, 1 minus 0.63 over 78. And let's see, this all gives me 0.055. So I have to do 0.63 minus 1.96 times 0.055, and I have to do 0.63 plus 1.96 times 0.055. That's going to give me my lower value of my confidence interval and my higher value of my confidence interval. So when I calculate each one of these, I get 0.523 and 0.737. So what we can say about this gives us our interval. We are 95% confident that the interval from 52.3% to 73.7% contains the true proportion of students who carry backpacks. Now we can use this same information and now calculate a confidence interval of, let's say, 90%. Okay, so now what's going to happen here is as we are less confident in our interval, the interval itself is actually going to become smaller. We're going to narrow down the interval, but we are not quite as confident that our true value of p is going to fall in that interval. And that's one thing with confidence intervals, that's just kind of the give and take that you have to have. The more confident you are, I could be 100% confident that my p-value falls between negative infinity and positive infinity. That doesn't really tell me anything though. I could be 1% confident that it falls between some very tiny window, and that would be nice if it really did, but if I'm only 1% confident in that, that also doesn't help me very much. So you've just got to kind of adjust and make that decision based on your data. So if we're doing a 90% confidence interval now, we are going to use our p hat, which was 0.63 plus or minus, and we need our critical value. Now from that list, the 3 critical values that we need to know, we have 1.645, okay? 1.645. So that's going to go in as my critical value, and our standard error, again, is 0.63, 1 minus 0.63 over n, which is 78, and we're doing the square root of that whole thing, which from the last problem I found to be 0.055. So essentially for this one, I'm doing 0.63 minus 1.645 times 0.055 and 0.63 plus 1.645 times 0.055. So for that, I've got 0.539 and 720. So my confidence interval now, I'm looking from 53 to 72. So this was my 90%. My 95% from the previous problem was 0.523, 0.737. So you can see that I've narrowed down my window just a little bit in this one, but I've narrowed it down, but I'm also a little bit less confident at what I'm stating here. I'm only 90% confident that the true value of P falls between these two values. Okay, so that is just a little bit on critical values.